In the early 20th century, startup film companies escaped the Northeast because of unreasonable patent restraints. California offered fantastic sunny weather and a variety of stunning landscapes that made dazzling new screen stories possible. These exterior epics naturally gave way for the need to shoot elaborate interiors as well. The earliest movie studios allowed daylight onto interior sets, but shooting time was limited to the daily sun cycle. Nationwide, the appetite for movies was growing exponentially, and it soon became apparent that artificial light was needed to increase production time and expand the writer's dramatic tool set. And as a cinematographer, I have another theory for the speedy development of artificial light sources. Hello, I'm Mark Vargo. Artificial light has been a part of filmmaking for almost 100 years. The early lighting instruments had to be very powerful due to the slow speed of film stocks at that time. These lights were so bright, actors could become temporarily snowblind. In this video, we'll talk about the physics of light and color, the evolution of cinema lighting, and why you might choose one style of fixture over another while planning your production. So let's get started and let there be light. Visible light occupies a tiny slice on the electromagnetic spectrum. Each color is defined by a wavelength and quantified as nanometers. The human eye can see between 400 nanometers, which is violet, all the way to 680 nanometers, which is red. Violet and blue are shorter wavelengths but contain the most energy. The longest visible wavelengths are represented as oranges and reds, and they produce the least amount of energy. Knowing these basic facts relates to color temperature, which is quantified in degrees on the Kelvin scale. And that's important because lighting instruments are available in two different color temperatures: daylight or tungsten. The year is 1802. Behold, it's a carbon arc, the world's first battery-powered artificial light source. This astonishing new invention stunned the world, but it wasn't until 1876 when the city of Paris replaced their gas-lit street lamps with new carbon arc fixtures. 3 years later, Thomas Edison introduced the world's first incandescent light bulb. It is this breakthrough that is vital to the development of cinema production lights. Except for intensity, there is little difference between the old fixtures and those available today. A cinema light has three main components: a light bulb, a reflector, and a Fresnel lens. The early designers needed a way to magnify and collimate the source, so they borrowed Fresnel lens technology, which was developed to strengthen the beam in lighthouses. The light bulb and reflector are connected in film lights. When you move the pair closer to the lens, the beam spreads out, and this is called flooding the lamp. As you go the other way, the beam narrows and intensifies. This is called spotting the lamp. A candle might look bright to the naked eye, but in fact, it gives off very little light. This gray card is 1 inch from the flame. A spot meter is a good choice for a reading in this situation. The sensitivity is set at 500 ASA, and the shutter speed is a 50th of a second. That gives us a 5/6. Now let's move the gray card 2 inches from the flame. 2/8. By doubling the distance from the source, we lost 2 f-stops, and that's 4 times less light hitting the gray card. Let's conduct a similar experiment, but with a larger source, an airy 1K Fresnel. That's equal to 10 100-watt light bulbs. The spot meter is still set at 500 ASA, with a shutter speed of a 50th of a second. The gray card is 7 feet from the lamp. F11. Now let's place the gray card 14 feet, or twice the distance from the lamp. 5/6. And that's 4 times less light. We are proving a phenomenon in physics known as the inverse square law, and this states double the distance from the source, lose 4 times the intensity. And for us photographers, that equals 2 f-stops throughout the entire universe. Fresnel fixtures have been a part of filmmaking for decades and are still considered the workhorse of our industry. Fresnels emit beautiful light, lustrous and smooth, and because of this, they are the only bright light I'll point directly at an actor. Sealed beam lights have many applications, and very few of those are subtle. These are great for illuminating large areas, and when I need a lot of bounce light, I'll use maxi brutes. You can spread the source by fanning the banks, and output is controlled easily as each bulb has its own switch. You can also make great fire effects by connecting these lights to a dimmer via a DMX control cable. Open face fixtures are good utility lights. I use them for bounce lighting and on night exteriors as specials on building fronts and for uplighting trees. A soft light is an old-school, self-contained, portable bounce light. These always feel warm to me. I prefer a bicolor panel light so I can fine-tune the color temperature to match the other lights on set and without gels. A Lico is a versatile, affordable, and grip-friendly miniature spotlight. The ellipsoidal lens creates a sharp, narrow beam that can be cut with these internal blades and then defocused by sliding this lens barrel in and out. This feature is handy for highlighting set dressing without creating any spill. There's also a slot for patterns, which can be used for dramatic effect. An HMI is a daylight balanced lamp. The fixture requires a ballast to ignite the bulb and maintain the proper voltage frequency. They are available as a par light with interchangeable lenses in a traditional Fresnel configuration, and now balloon lights can be rigged with daylight bulbs. For the last 40 years, HMIs have revolutionized the way we shoot location exteriors and practical sets. Kino Flow fluorescents are soft lights. The tubes are available in many sizes, and the fixtures can hold multiples of tungsten, daylight, or specialty tubes for blue or green screen setups. These lights are powered by high-frequency ballasts that reduce flicker and increase intensity. Kinos are popular and make great beauty lights, but they don't project well and therefore make it difficult to shoot a wide shot unless built into the set as a practical fixture. LED lights are amazing and are changing the art of cinema lighting. Cool burning, powerful, and efficient, the latest fixtures are bicolor and dimmable. A gaffer friend of mine says that the Arri L7C is the light of the future. If you were saving to buy a movie light, you might want to consider an LED. And remember, no gels and no scrims. Now we know that cinema lights adapted Fresnel lens technology to magnify and collimate the beam of light. For decades, movie lamps looked basically like this and were available in a variety of sizes. Bigger lamps are brighter, but they require more electricity, larger power cables, and that eventually led to the development of large portable power generators. You don't always need a generator. I shot a night exterior scene with just 3 of these, and it worked out great for the story. Check out your local hardware store. Chances are they'll have a wide variety of powerful LED flashlights and versatile work lights that might help you on your next production. Thank you for watching. Adios for now. I'm Mark Vargo.